Hi everyone, welcome to Kopi, and today we are super excited to have Stanley, George and Phone together with us, and we have a couple of minutes before we start our session, so we wanted to get to know everyone a little better. Feel free to participate in the conversation as well. So for the speakers we have with us today, could you share with us what movie or show you watched recently? What you recommend to our viewers? Anyone, feel free to go ahead.
What's on your watch list, Phone?
Like last week, like you mentioned before, I really watched the Frozen 2. Yeah, I watched in the cinema before, and right now I watch in Thai, and they sing a song in Thai. Yeah.
Oh wow.
Like,
I didn't realize that Disney actually translate the entire song in Thai. I can imagine the dialogue, but I didn't realize the music too. I must hear it. It must sound really...
I think it translates into like 23 languages, something like that. Yeah. I really like it.
Wow. I did not know that.
I'm fan of Disney.
Do you watch it on Disney Plus?
Yeah.
Oh, nice. Cool. What about the rest? Stanley and George?
Maybe Stanley go first.
I didn't know we include movies. But yeah, I don't normally watch series. So I think the last movie that I saw was Cruella. Yeah.
It's a good one.
Yeah, it's pretty good actually. It's surprisingly good. Like, okay, I don't want to spoil it, but like there was some like very brilliant thing that I found. Like, oh shit, I didn't think of that.
I love how they are telling this story of the villains in the show, right? Of like how they came to be, and Emma, what's her name? Emma Stone, was it?
Yeah.
She is amazing. I love her.
She's real good.
You watch it if you haven't already.
Naughty said Loki was great.
Oh yeah, I heard so, but haven't.
Is Loki a movie or a TV series?
It's a series.
It's a series, yeah.
On Disney Plus, huh?
Yep.
No, sounds like everyone is on Disney Plus.
I think so.
Maybe I should get one.
So what are you watching outside of Disney Plus, George?
No, so I'm the other side. So I'm like the person that pirates movies. So
maybe not. Okay.
Yeah.
We did not hear anything. Okay.
Yeah.
So what show did you watch recently?
No, I don't watch show, but I went through like Avengers 1 to 3 with my girlfriend because she has not watched Avengers, so we just go through the entire thing like a marathon. Yeah.
I'm pretty sure if you get Disney Plus, you can watch all 3 of them, but yeah.
Maybe I should.
I think we are turning to a Disney Plus advertisement right now.
Yeah.
You get referrals, Janice?
Sorry?
You get referral from Disney?
Yeah. My favorite show that I'll refer you to watch on Disney Plus is Hamilton. Best musical ever. You have to watch it.
Oh, I didn't know that's available on Disney Plus.
It is. So I watched it live in London, and then when Disney Plus was having it, I watched it again, and it's so amazing seeing it so up close. Yeah, you guys should watch. Like, it's really cool.
Let us know if you have any other recommendations in the comments. Thanks for joining us, and without further ado, we are gonna move our speakers backstage to get the session started. So see you folks shortly. Hi everyone, I'm Jia Xing.
And I'm Janice, and we're both from the Google Developer Relations team looking after our developer and startup community in Southeast Asia.
And thanks for joining us for Kopi today. We hope everyone is keeping safe and well wherever you are from. And do leave a comment in the live chat and let us know where you are tuning in from. Our speakers today are from based in Singapore, Bangkok, and Malaysia. So we are really excited for their topics as well.
And in case if you're joining us for the first time today, let's share a little bit about who we are and what this is all about. So Google Developers Space is a home for developers and startups from around the region to come together to connect, engage, learn, and be inspired from each other. So we want to empower and connect the community to our people, program network, and technologies.
And Kopi Developer Space is a monthly open mic night for the developer community to learn, connect, and be inspired. So every month, a tech team is selected and developers submit their topics to be shared with the community. And this month, our topic is on Google Cloud Platform. And we have a total of 3 speakers joining us. They will each be sharing for about 10 minutes, and you're welcome to submit your questions on YouTube or Facebook, wherever you're tuning in from, and we will answer them after each speaker. So for this Kopi, we have George Wong, who will be sharing how you can use Cloud Run as a webhook for data ingestion. Stanley Nguyen, diving into zero config tool for deploying Go app on K8 Kubernetes, and Phone, who will be sharing how to develop a data pipeline on Google Cloud.
So our first speaker today, George, is a data scientist at Setel who loves to build and tinker with solutions and is in the pursuit of building the next great product through data science. His first session today will cover Cloud Run and its comparison with Cloud Function and solving problems through ingesting live events data. I think we all need that, and how it's being used for live dashboarding purposes. We will also be going through the architecture of this solution so you can have an understanding of how you can make this happen to Google Cloud Platform too. I'm super excited. One of the great topics I think is relevant for all of us today. So thank you, George, for sharing. We're looking forward to hear about your project.
Hey, hi guys. Welcome to my talk today. I think like Janice had mentioned just now, I'll walk you guys through how Cloud Run is used as a webhook for data ingestion and also on building live-ish dashboard. I do hope that it's live, but it's close to live, so it's live-ish dashboard. The main outline today is I'll talk a little bit about me, and we will go through what is Cloud Run and comparison between Cloud Run and Cloud Function, problem solution, architecture, and can we do more with Cloud Run? Because I personally, after I know Cloud Run and using it for my projects, I fell in love with it, and I just want to share with everyone on how great Cloud Run is. So a little bit about me. I'm a data scientist at Setel, based in Malaysia, previously in AirAsia, Caltem, and also iCar. I love machine learning engineering, especially MLOps, and the technical side of things like data engineering, data science. I think why? Because I like to get hands-on, and also as you can see from pictures, I love to play with use tool, and loves to build and experiment with different solutions for different problems. I like solving complex problems using data science. I think that's the way to go for me. So that's about me. With that being said, let's get right into what Cloud Run is. So it is a fully managed compute environment for deploying and scaling containerization without worrying about the provisioning of machines, configuring clusters, or other scaling. So with all of this jargon, right, to put it simply, Cloud Run is something that helps you to run your container, without you worrying about the infrastructure side of things, like provisioning machine, configuring cluster, and auto-scaling it. So it makes your workflow much easier in terms of deploying and scaling your apps. So this is what Cloud Run is about. Why I love it, I think some key features here would include, one thing is no vendor lock-in. Because it's built on open source standard Knative, you can easily port over your application to on-premises or any other cloud environment. And it's also fully managed, and it helps abstract away all the infrastructure management. So what this does is that microservices deployed in Cloud Run can scale automatically just based on the number of incoming requests. You don't have to worry about configuring a full-fledged Kubernetes cluster, and it can scale to 0. And somehow it will reduce the cost for you. Another thing that I love about Cloud Run is it offers traffic splitting or traffic management built into it. You can use Cloud Run to split traffic between multiple revisions, and also perform your gradual rollouts for your product, for your model, for your app through Canary deployment, blue-green deployment as well. And there's also many other key features like custom domains and also automatic redundancy. But I'll not talk about them, 2 extra key features, but this is the key features that I love and how it made me choose Cloud Run over Cloud Function for my project. So like we said just now, we want to compare between Cloud Run and Cloud Function. So I think first thing first is that in order to run Cloud Run, it requires you to have expertise on containers, building containers and operating them. But for Cloud Function, mainly you just need your code. For Python, you just have to write your main function. That will be enough to run your Cloud Function already. But another thing in terms of handling concurrency, both of them can handle concurrency, but Cloud Run handles it much better with a lower cost in long run. I think we will get into this later as well on why it's much better to choose it over Cloud Function for concurrency. And as Cloud Run is running on container, then you can build it with any languages. But with Cloud Function, it's only limited to Python, Node.js, Go, and many other else. But I think I'll just highlight these 3 of the languages involved here. So, like we said just now, use Cloud Run if. So for me, I use Cloud Run because maybe because my language is not supported on Cloud Function, then I choose Cloud Run. But mainly I'm focusing on the large volume and concurrency involved because at the end of the day, it's event data that I'm working with. We'll get into this later on what kind of event data. So in terms of large volume and concurrency, Cloud Function, it's not good because actually we are sending one request at a time and spinning up each function instance. So every time you send a request, you are spinning up a Cloud Function instance. But if it's Cloud Run, then it's configured to send multiple concurrent requests. So this is very helpful in improving your latency, reducing your costs if you're expecting large volume, especially what we're working with back in my old company. And also a very specific thing, which is longer request timeout. Because it is a webhook, sometimes we would expect a timeout. So in terms of longer timeout, for Cloud Run, it is as high as 60 minutes. But if it's Cloud Function, then highest that you can go for timeout is 9 minutes. So that's why I choose Cloud Run over Cloud Function for my specific use case. So once we talk about what Cloud Run is, what it offers, and why I choose Cloud Run over Cloud Function, then we need to talk about how it works, right? So I use it as a webhook. But there's many other ways that you can use Cloud Run, how you can trigger it. 3 main thing or 3 main trigger that I've worked with, and also and there is other trigger, but I just put 3 of them because 3 is a better explanation for me. So in terms of webhook, I'm using a HTTPS request to trigger my Cloud Run. So you have to understand that for each Cloud Run, they actually have their own HTTPS URL that you can trigger it. So Cloud Run comes with its own HTTPS URL. So some possible use case here, if you want to use it for a webhook, custom web API. In terms of PubSub, typically we use PubSub to trigger Cloud Run because it's useful to talk between GCP services, and you can push your PubSub message to the Cloud Run endpoint, and the message will be subsequently delivered to other containers as HTTPS requests. Another simpler thing, if you want to use it maybe for scheduling something, you can use Cloud Scheduler. It's offered by GCP. You can use Cloud Scheduler to trigger your Cloud Run service on a schedule. So this is very similar to your cron job. So yeah, it's Cloud Scheduler as well. So my use case here is using Webhook, which is through the HTTPS endpoint available. So let's get into the problem. So the problem here is that we want to ingest events data coming from third-party vendor or a third-party data source for your case. And the business stakeholders wanted to monitor this live data on a live dashboard. And since it's live data, it's streaming data, then we need the services, or we need Cloud Run to be able to handle up to 100 events per second, and also handling concurrency, because every time a user did something, different users are doing it at the same time, then you would need it to be able to manage it concurrently. And we need to transform the data before loading it to be viewed by the dashboard. And also, when no one is using it, then we have to scale it down. Let's say if it's midnight, no one is doing anything, then you need to scale it down all the way to maybe 1 or 0. So that's the problem that we're working with, and I've chosen Cloud Run for it. I will not be showing any code at the moment, because I think it's not good to share code that I've worked with, since it could be proprietary, or it could be let's just say we don't show code here. But I'll walk you through the architecture, and I'll walk you through the solution that I have in mind and what we have worked on at that point in time. I think it's still working on right now at the moment. So this is the entire architecture. It might seem overwhelming at first, but I will try to break it down bits by bit. And so let's start first by understanding how we build Cloud Run and how do we get Cloud Run up and running first before we use it as a webhook. Let's get it done right away. So in terms of getting Cloud Run up and running, I can't find a picture for Cloud Source Repo. So we start off with Cloud Source Repo here, where I put all my code and store all my code on Google Cloud Source Repo. It helps me to keep track of my code changes in terms of code versioning. Then after that, it will trigger every time I do a new push or new code, committing it to the Cloud Source Repo, then it will trigger a new build by Cloud Build. So this is part of the continuous deployment aspect of things. Then I will build a new container based on the latest code that I've committed. So in order to build a container, what you need is just Python file, Docker file, app YAML, and your requirements.txt file. So this would generate a new container or a new image that you can run. So this container would then be stored in container registry, tagged by the latest tag. Maybe we tag it with the latest tag called tags, latest as the latest tag. So what Cloud Run will do is that it's very easy, hence why I love Cloud Run. We can just build Cloud Run based on the container that is available in container registry. So we'll be fetching the latest container, then performing, if you want perform rollback, you can perform rollback. But for my case, I'll do a gradual rollout. If it's the latest changes, I'll do a gradual rollout, and also split the traffic to test if it's working. So hence, that's how easy it is to run Cloud Run, because you can just build it based on the latest container. As long you can skip this step, there's other method to build Cloud Run also, but I chose to use the container method because it is the easiest method for me. And you can also commit your container to container registry from other tools. If you put your code in GitHub, you can do that too. But I use Cloud Source Repo. It's much easier for me. I just put it there, then it will trigger the latest build and build the latest container and just build the latest Cloud Run. So once we have Cloud Run ready, it's ready already. It's ready to be served to our user to be used. Then let's get right into the use of Cloud Run. So as the problem said, we need our vendor to send in the data. So I call it the external party. They will send in data in the form of pause requests through the URL that's available, that is available to them from the Cloud Run endpoint. Then once they send in the data through pause request, Cloud Run would be spin up to be able to handle that request. If there's 1,000 requests, 100 requests, then multiple Cloud Run would just scale up to handle that. So when the data is coming in, once we have the data ready, then we will have to transform before loading it into GCS. So Cloud Run for me is just to handle the data and transforming it before loading it into my cloud storage or my GCS. So once we store it in GCS, we already there's no point to talk about Cloud Run already, but I just want to expand it, the entire solution, so people can see it. So after that, we will have a cloud function to cloud function and cloud scheduler. Cloud scheduler would trigger the cloud function to load the data from GCS into BigQuery. So this will be done in a timely manner, 30 minutes, I would say. And why I don't use Cloud Run to BigQuery? Because cost involved. If you were streaming data directly to BigQuery, it might cost a lag. So the way I do it is I put it into GCS first, then I use Cloud Function to load the data into BigQuery. Then once that's done, then we have our entire solution ready already. You have your data in your BigQuery, then you can just use Data Studio to fetch the latest data from BigQuery, and then your stakeholders can enjoy and see the metric, how the metric move, how the numbers move in terms of their daily numbers. So that's how you do it, using Cloud Run to ingest data and putting into GCS, and eventually showing this data to your stakeholders and using that to make decision. So can it do more? I would say yes, Cloud Run can do more. In terms of asynchronous microservices, let's say if you have different Cloud Run, you want to have different Cloud Run talking to Cloud Run together, you can do that. You can use PubSub to handle that. You can do that. Scheduled maintenance job, yes, you can do that as well. Especially, like I said just now, you can use Cloud Scheduler to trigger it. Then you can use it to do schedule maintenance. Web services, websites, yes, you can use Cloud Run to host websites. But here's the thing: if you want reliability, I think I would suggest you to go for App Engine, because it's more suited and it's already been there for a long time. I think suggesting you to use App Engine will be better for websites, and App Engine can just handle more stacks, I would say. In terms of web services, REST API backend, you can use it as well. Like our case, I think we are using the same thing. Lightweight data processing, yes, you can. Let's say if you have streaming data that comes in, maybe you are running a video streaming website, or you are trying to do data transformation within your company, you can spin up a Cloud Run and use Cloud Run to handle that. I think some people use it to transform PDF to Google Sheet, if not mistaken. Those are some of the lightweight data transformation that you can do with Cloud Run. And yeah, I think that's all from my side. This is a very short talk. I hope you learn a lot from this, and how to use Cloud Run to your advantages, and how Cloud Run is useful for your case, and also how to build a semi-live dashboard. I hope it helps. So I think I end my talk here.
Thanks a lot, George. Yeah, I really love how you brought in like the business problem, and how you are using your solution so that the stakeholders, it's easy for them to understand as well. Yeah, I think meanwhile, if you have any questions for George, feel free to leave them in the comments section. I think we have one that just came in, but before that, we are gonna go through a couple of registration questions. So you mentioned earlier that there are some cases where people can use Google App Engine. So this is a question that's related to that. When do you use Cloud Run instead of Google App Engine?
So when can you use Cloud Run instead of Google App Engine? It would depend. Let's put it into the context of building websites. All right. So in terms of building websites, I think it'd be better to go for Google App Engine. So to answer the question on when can we use Cloud Run instead of Google App Engine for website, website you need your website to be available every single time. So App Engine always have a single instances running. So because of that, your website is always available. So it's always there. But if it's on Cloud Run, then your user might suffer because they would have to wait maybe a few milliseconds for the website to spin up from the trigger. So I think in that case, you should use App Engine instead of Cloud Run. And given the fact that there is Google App Engine Flex environment now, I think it's more better. It provides a more, how do we call it, like a separation between when should you use App Engine or Cloud Run. Yeah, I hope that answers the question. Yeah.
Yep, I think it does. If it doesn't, feel free to leave it in the comments and George will get back to you.
And shall we do the one from the audience since you're here with us?
Yep.
I think we've got Hafiz. His question is, will Webhook be better in real-time data fetching, or is it better to use PubSub? What do you think?
I think, Hafiz, I think it would depends though. If it's internal, then I think internal services, I think PubSub will work. Because for my case, it's outside, like external vendor, so I choose to use Webhook instead of using PubSub lah. I just use Webhook, and this Webhook is on Cloud Run because I needed to run transformation. So yeah, I think specifically for my case, it's like that. I hope I answers your question.
Yeah, if you've got a follow-up question to that, you can just put it in the chat and then we'll address it again.
Yep. I think you have a fan as well. Haziq. Say, yay, George.
Hi, Haziq.
Hi, Haziq. Thanks a lot, George. If you are viewing and you have any questions, feel free to leave them in the comments. George will be able to answer them there as well. And I think now we are happy to move on to our second speaker. Thank you so much, George.
Bye.
Yeah, do join us at the chat to answer some of the questions there while we move on to the next speaker.
So for our next speaker, we have Stanley Nguyen, software engineer at Xendit. He is also one of the organizers of Go Singapore Meetup and actively shares his knowledge about Golang with the community. So if you have been watching, following us on DevSpace, you would see that he's really familiar. Stanley will be sharing how Go leverages on the import path approach of Go to simplify the whole process of building binary container image, publishing image, and applying to Kubernetes into a one-liner command. The stage is yours, Stanley.
All right. Hey, folks. So thanks Justin for the intro. As Justin has mentioned, today I'm gonna talk about Go, a zero config deployment tools for Go applications. So we can make builds and deploys great again for our application developers. So before I begin, here's just a bit about myself. I'm Stanley, currently an engineer at Xendit, building payment infrastructure for Southeast Asia. I'm also one of the co-organizers for Go Singapore Meetup. So if you haven't joined yet, we are welcoming you. So I dabble in Go, Node, and deliver my apps to production with Docker and Kubernetes. So what exactly is Go? Go is a tool for building and deploying Go applications to Kubernetes. Go is built around the Go import path dependencies, which I will explain in a later sections of the talk. But before that, let's take a deep dive into the problem that Go is made for. So I'm assuming that most of us in the audience are familiar with containerization and Docker, but for those who don't know what containerization is, it's basically the technique of bundling all application components with its dependencies, configurations, and runtime environment as a self-contained module to be run in a host machine. So this is a basic process for Dockerizing a Go application and deploy it into a Kubernetes clusters, which involves compiling the binary, building the Docker image, publishing the image to Docker Hub or whichever repository you are using, and finally applying the deployment to your Kubernetes clusters. Fast forward to the age of microservices. Now we have to manage tons of different builds, each one of which has their own sets of Docker files. Things starts to grow out of control with lots and lots of configurations in form of Docker files and YAML files. So now some of you might be thinking about tools like Scaffold that can wrap this whole entire process for different languages and Docker files to make this process more manageable and faster. However, as application developers, we actually still need to write a lot of Docker files and typically even more YAML files to describe all of these orchestration. So these two actually only help us to automate the process, but we still need to write a lot of configurations. So actually, there's a pattern here that we can optimize in our development effort. The major pain point is that Dockerization process is too invasive in my development environment, requiring a lot of efforts for configuration. I'm not saying that this is not necessary, as at times we would still need to carefully handcraft our deployments based on the technology or business requirements. But at most of the other times, we actually have the same build configuration for majority of our applications or services. So Ko is targeting to solve this problem by providing a way to eliminate the needs for build and deploy configurations to eventually make containers invisible infrastructure, and one less thing for application developers to worry about. So this is the new model of our deployment process that Ko is constructing. Instead of having multiple Docker files, building images from each one of them, and pulling from the published repo to deploy to our Kubernetes clusters, we actually just need a one-liner that will handle everything to get our microservices up and running in the clusters. This is particularly useful for Knative developers, as there's a need to manage a very large numbers of containerized images. And as a matter of fact, Ko was originally made for Knative developers and live inside one of Knative's repositories before it got extracted out into a separate repos and as a standalone tool. So how does Ko achieve that zero config deployment workflow? It leans into the Go idiom to simplify the whole process and eliminate custom configurations. In the same way that your local machine is using import path, Ko use Go import path to refer to the Go command that starts containers. So our concerns are now simplified from Docker build plus Docker publish plus Kubernetes into just Ko. So what are the features that Ko has to support this entire process? So first we have Ko publish, which simply builds and publishes images for each import path that was passed as an argument. The main function of the program must be in the path for Ko to build and publish a Docker container. So Ko publish also support relative import paths and when in the context of a repo on Go path. So where does Ko publish images to? By default, Ko will try to publish to your local Docker repo, but we can easily reconfigure that with this environment variable called Ko Docker repo. Next up, we have Ko resolve, which will take the Kubernetes YAML file written in the Ko convention in the same way as kapply and determines which Go path to build, Dockerize, and publish. The output of Ko resolve is a concatenated YAML that with import paths replaced with the publish image digest. And finally, we have Ko apply, which is parallel to kube control apply actually. It acts on the output from Ko resolve. And as developer make changes to their Go application, Ko apply could actually be very useful to rapidly rebuild, repush, and redeploy your applications. And in addition to that, we also have Ko delete, which is just a convenient wrapper for kube control delete to clean up resources created through Ko apply. While Ko aims to have zero config, there are times where developers would want to override certain default behaviors. You can achieve this through Ko YAML file. this file can be included directly in the folder where code is invoked. So what are some of the options that code YAML offer? So the first option available is default base image, which can be useful if we want to switch out the distroless default base image with some other specific image that fits our requirements better. And we can even do this for every single binaries that our code cluster use by specifying the path with which the base image we want to use. Now, some of you might be asking as well, how do we include static assets for our applications to be deployed by code? So code data path environment variable is the answer. All content inside this path will be copied to the image and made available inside the images under the same environment variable. So code data path actually defaults to code data if not specified. This is drawn from an another idiom in Go test, where test data will be included and made available for Go test. All right, enough talking. So I'm gonna show you code in action. So in here, I have my standard Go application. So, okay, Go cluster to be specific. So I have like five different applications, which basically just serve a static image with some text. Yeah, and then I also have my custom Docker file written here, which build the app and then package it in the final image with the data from code data. I'm using code data folder here because it's easier to draw comparison when we are doing the exact same thing as code. So yes, for all of these five applications in my cluster, I'm actually having the exact same Docker file, which from my own experience, is always the case for most organizations, because we actually have templates in how we want to build things, and we don't want to stray too far from that unless it's necessary. So yeah, so this is how I'm gonna build my application and deploy them without code with the standard Docker process. So here I have started my a global Kubernetes cluster using Minikube. So yeah, takes some time to start it. So I started before the presentation, but yeah, the cluster is up. So now what I'm gonna need to do is to go in to build each of these applications. So I'm gonna Docker build, tag them with the right name. Oops. And yeah, so I'm gonna have to build an image first. Oh yeah, my Docker is running. Thankfully, we didn't have to wait for Docker to boot up. So yeah, I'm gonna have to build my image, wait for it to build. All right, taking some time. All right, so I'm just gonna show you my Docker Hub as well to see that the images are pushed. So there's no images from the local Hello Universe application that I'm trying to demo on my Docker Hub yet. It's taking some time to build because I just put my local Docker images, so downloading and extracting. Justin, I think if there are questions, we can start addressing immediately while we're waiting for this So yeah, this is the kind of pain that we have to go through every day as developers.
Okay.
That's why we take so many coffee breaks.
Nice. All right, we can go through a couple of registration questions first while we are waiting for it to load.
Actually, it's just completed. So now I'm gonna push my image to Docker Hub.
Okay, we're just gonna stay on screen so you can talk to us and there's no awkward silence.
Hang on, it doesn't work.
This is the stress of coding live.
Oh, sorry, miss out my surname. Yeah, so it's pushing now, and it doesn't just end here because I have another 4 applications that I have to get to Docker Hub before I can finally launch my clusters. So yeah, but the subsequent build will be faster because now I have all the base images, all the base Golang image in my local. So yeah, to make sure that I don't have to retype all this, I created a make file that I'm gonna run now to build everything and push to Docker Hub. Yeah, so yeah, in the meantime, I'm just gonna address some of the questions. So yeah, what's the first questions?
Yep. Are there any similar tooling to code in other programming languages?
So actually right now we only have Go for Go. Go is like Kubernetes plus Go, right? So I hope that we have
I did not realize that.
Yeah.
Nice.
We like puns.
Yeah, you can share the Kopi pun.
But yeah, it's actually not that hard to build a tools like this. But the main idea is that we want to have a base conventions that most of the time we don't stray from, and then the tools will just assume that we are following that conventions. So that's the idea of code. So instead of like offering a lot of configuration, we choose convention over everything else, and I would say that it works 95% of the time. Yep.
Okay.
I think we have a couple more questions for you. And if you'd like to ask Stanley any question, you can also drop it in the chat and we can bring it up. But now we can address some of the questions that was brought up during registration. Hi, Shafras.
All right. I think I should decrease the number of applications that I want to deploy, but it's too late now. Yeah, I think you got one more question from registration.
Yep, let's go through the second one. How do you foresee enterprise companies in adopting the tool, seeing that there's a large emphasis to split the deploying of applications away from CI processes?
Yeah, so it's actually not just for enterprise company, but as we see technologies mature, right, and like the complexity get higher and higher for like all of these very commoditized stuff, I would say. So like infrastructure nowadays is pretty commoditized. You don't want to do it yourself. You want to get someone else to manage it for you. So I think this is something that doesn't directly deliver business value, but we still need to get it done. So I think it would be very benefit for companies to adopt. I think it's not just benefit for them to adopt, but like they would definitely adopt convention over configuration. We do that in Xendit. Like we build a lot of our internal convention. We build a lot of our templates that every time someone wants to build a new application, they just make use of them instead of like trying to configure everything from the start. Oh, all right. Yeah. So just nice. All of the images just got pushed to Docker Hub. So.
Okay, we are just gonna remove ourselves for now.
Yeah, thanks. you can stay if you want. All right. So yeah, I have all my images here, and then now I'm gonna deploy them to my local Kubernetes clusters. So like, yep. Oh yeah. So these are the Kubernetes config that I'm using. So I'm using these images that I've just published. And yeah, so this is like the standard process without any automation that we are trying to get from code. So now that it's still creating my bots. See which one is ready. Oops. Yeah, gonna take a while to boot up as well. Okay, I don't like awkward silence, but yes, it's up. So yeah, so I have 5 of my services here. I'm gonna show you that it's actually running. You wanna travel to Earth? Actually, no, let's travel to Mars because we're on Earth. So right, yeah, the cluster is up and running. But let's try another service. All right, so that was a very arduous process, I would say, arduous at best. And now I'm gonna delete my current clusters and show you how everything that I've just done could be achieved with code in just a single command. So now everything has been removed. If I try to go back to the host just now, oh, why is it still running? It's not reachable anymore, so the cluster is down. So with code, instead of like having having a Docker file for each of the application, now I'm just gonna have this code import path inside my code style Kubernetes YAML. So that with that in place, I'm just gonna do code Docker repo, my Docker Hub repo, and code apply. So code will take care of everything else for me. Now I can go for a coffee break. But actually, it's gonna be quite fast that I don't even need to go for a coffee break as usual. Yeah, so code actually use the default base image is this shoulders one. So yeah, you can see here, it's using this base image to build each of my application. And then it built the Go binary. Oh, and I actually don't even need Docker to build with code. So yeah, I just turn off my Docker daemons, and yeah, there's no problem. I can do it another time without Docker. And there's no problem. So Go actually doesn't use Docker to build images. It's actually directly compile the binary and compress it as another layer on top of the base image. So yeah, now Go actually have pushed all my images to Docker Hub. As you can see here, and it actually have applied all of them and created the exact same cluster as as the one that we took 20 minutes. Sorry, it wasn't 20 minutes, but I think it was 10 minutes to create just now. So yeah, it's booting up. So Code did that with just a single command, and it was really fast because yeah, we are not downloading a lot of base images. We are not building each application individually, but like we build them concurrently in code. So like now, if I'm trying to access my application, service, I get the exact same result, and I actually only had to type one command, or I would say it's equivalent of like a single command run on your CD environment, and no Docker required. No Docker required. Everything is inside code. Yep. So that's the power of code. Yeah, and that's all, folks. Thank you so much for tuning in. And if you have more questions, you can ping me on my Twitter, or you can find the code in this repo.
Yeah, thanks a lot, Stanley. We have a question from YouTube, but because we are running a little tight on time, we'll leave you to answer the question there, and we'll move on to our last speaker for today. Thanks a lot.
Okay.
Hey, Janice, you're on mute.
1.5 years of running virtual events, and I'm still muting myself. All right. So last but not least, let's welcome our final speaker, Phone. So I'm going to pronounce your full name, Kamolphan Liwprasert, all the way from Bangkok. So Phone is joining us today. She's a senior machine learning engineer at Sertis, and she focuses on ML system on cloud and has a background in data engineering. She's a GCP certified professional with 6 of our certifications, and is also one of our recent Google Women Developer Academy graduates. So we're super excited to have her here today. We'll be exploring data pipeline options for data analytics or machine learning projects on GCP. We'll also see different options on how she's developing data pipeline and how to choose between the various options. And Phone will also be discussing Apache Airflow as well as a live demo to show you how it can be used. So over to you, Phone.
Hi, everyone. Yeah, today I'm very pleased to be here, and I'm going to present about developing a data pipeline on cloud for data analytics and ML projects. A bit of my introduction. My name is Phone Kamolphan Liwprasert. I'm a senior machine learning engineer at Sertis, which is an AI consulting company based in Bangkok, Thailand. I have some background in data engineering, and I would like to share with you. Yeah. For every data analytics and ML project, like we need the good data pipeline as a solid foundation. But because data is not always ready to use at the beginning, either the data is not clean or we don't have the pipeline to manage the data. And as we have listened to Josh's presentation before, the data pipeline is really in need, whether it is on cloud or anywhere. And we also need to think about the automation and scalability as the project goes. We also need the good logging and monitoring system to support 24/7 operation. Therefore, these are the main reasons why we need to build a data pipeline, and cloud will make it happen faster and easier. Today, I'm going to talk about why do we need a data pipeline? What are options on cloud for data processing, whether it is for storage, compute, or the data processing pipeline? And I'm going to introduce you to Apache Airflow, and let's see demo on the Airflow. Let's get started. First of all, why do we need a data pipeline? From the points that I have mentioned earlier, the purpose of data pipeline are to ingest the data from multiple sources, because the data can be from database, REST API, and we will need to gather all kind of data into our project. Secondly, we will need to transform the data or clean the data to ensure the best quality of the data. With a good quality, we will make the model better. Lastly, we will need the automation of the process, because the manual work is really tedious, and if we leverage the automation, it will make our life easier. So what are options on cloud? For choosing the data storage decision tree, here it is from the Google Cloud Platform. Let's focus in this part about the data analytic workload. Zoom into this part, we will see the option in data analytic workload. For example, if we are going to choose the low latency use case, I recommend for Google Cloud Big Table, because it is the NoSQL column database, and it is very fast and low latency. But in the more generic use case that we will need that we need data warehouse, I suggest Google BigQuery as the serverless enterprise data warehouse. It has a SQL interface, so it will make it easier to interact with data. And the last one is about the Google Cloud Storage. Of course, like I think many of us use it as the staging area, and it is the best option for object storage and data lake. Let's coming into the compute option. Google Cloud provide a large wide range of computing, starting from the infrastructure as a service, like a VM for Google Compute Engine, and to the function as cloud function. I think you may heard many of these, like some of these that Josh already mentioned before. I'm glad that he did the presentation before me. And let's starting from the Compute Engine, which is the VM where you can lift and ship your application directly. And next, if you need the Kubernetes cluster, it is a GKE where you can get the managed service of Kubernetes cluster fast and easily. Then let's move on to the Cloud Run. Cloud Run is the serverless container where you can just deploy your container instantly and easily, where you can, and it is not limited to one language. Like you can see how power of the container do. The next thing is about the application platform for Google App Engine. You can deploy the whole application platform in Java, Python, or Go into the App Engine. And last one is a cloud function, where you can just deploy your function and you will get an endpoint. It's very easy. So these are the basic options that you can get from the Google Cloud. And then when we move on into the data processing option, so regularly we will need to think about two things. First, it is where we process data, and secondly is where do we control the workflow or scheduler to automate the job regularly. For the workflow and scheduler job, Google Cloud has provided a cloud scheduler where you can put the scheduler in cron format. Similarly, in the server in cron, and you can trigger it into with HTTP endpoint or PubSub topic. Then the next one is a new service. It's called Cloud Workflow. You can define the workflow as a code and let it run step by step as a pipeline. And for data processing option, first we have the option of serverless option, as George has mentioned before. It is the Google Cloud function and Cloud Run. You can create an endpoint and trigger it on demand. We will go into more detail in the later slide. And the second option is for the process the big data. We have the Google Cloud Data Pod and Google Cloud Data Flow here. So we can manage it for the Hadoop job and also the streaming pipeline as well. And lastly, I'm going to introduce you to the Cloud Composer, which is the managed Airflow service, which this one it can cover on both cloud data processing part and also the workflow and scheduler part. Let's see each option in detail. On the first option, it is the low cost and serverless option. In this one, I will mostly focus on like a Google Cloud function and Cloud Run, as it will trigger every time that the event is triggered by either REST API or PubSub topic. It is very good for the light workload, because some of them may have the limited of time or it always can time out, but it can scale very well with this one. So to sum up the benefit of this one, as maybe you heard from the previous section, first, it is serverless because it's fast and easy. You can develop it and build it as container and deploy it right away. And second, it is low-cost solution. Google Cloud has provided quite generous free tier, and you can start from zero and pay as you go. And lastly, it is suitable for light workload. Because of the compute, it is maybe not suitable for the big data, but you can also combine it with other services to make a new possibility. Next is the option 2. We are going for the big data solution. So I would recommend Google Cloud Data Proc and Cloud Data Flow for the data processing, because both are already designed and support for big data workload. You can create a cluster to process the big data job. And for Cloud Data Proc, it is support the wide range of Hadoop framework, whether it is Spark or Hadoop or Apache Flink. It also support in the Data Proc as well. And similarly, the Cloud Data Flow is the newer design. It is the unified data pipeline with Apache Beam. With Apache Beam, it can also support the runner that also include Apache Spark and Flink. But with the Apache Beam, we can use the same pipeline for batch or streaming job in the same pipeline. And it is also an open source project as well. So let's see the benefit. First, it supports big data framework, so you don't need to think about how it will handle the large like the huge workload. And secondly, it is highly scalable and it has the high availability because of it create a cluster, and with the manage of the cluster, you don't need to think about how it will distribute the job. It will do everything in the background. And lastly, they are open source. You can choose whatever, like the favorite framework that you like, whether it is Spark, Beam, or Flink. So it is no vendor login. You can run anywhere as well if you have the cluster. And lastly, for the Cloud Composer option, Cloud Composer is the managed service of Apache Airflow, which it has a very popularity among ETL tools. And with the power behind the scene, Cloud Composer uses the power of Kubernetes engine and the Cloud SQL together to make it highly scalable and fault tolerant. But for the Cloud Composer, I will suggest it as an orchestrator because it is good to build a pipeline, but sometimes with the with the high workload, we still need to integrate with the previous option for the big data. Yeah, but for the benefit of the Cloud Composer is, first, it is easier for maintenance because you can have the Apache Airflow cluster in one click. And secondly, it provides scalability and reliability with Kubernetes engine, of course. And lastly, it's suitable for the large number of jobs that if you have a lot of ETL jobs and you will need to ingest data in the past, you don't need to miss any SLA. I would suggest it because Airflow can manage this one very well. And yeah, as I said before, Airflow can integrate with all other services, which I will talk about the third-party integration soon. Okay, let me introducing you to the Apache Airflow. Apache Airflow is the popular open source project that it is made for ETL and data pipeline for orchestration. It is maintained by Apache Software Foundation, and all codes are in Python. It's very easy to learn and to use. And lastly, it can be run locally as well. For example, you can run Apache Airflow in Docker for the local development, and you can run on cloud as well. So for the Apache Airflow, currently it got 22,000 stars on GitHub, so it's quite really popular. Airflow is rich in third-party integration. In the word, it's called provider. It means it provides a package to connect into other services, not only Google Cloud, but also other cloud platforms as well. And you can also integrate into some of other famous services. And you can find the code of integration on the GitHub source code here, where you can also pull the PR to make change and add any of the providers you like. And Apache Airflow also has the nice UI, where in this UI you can see all the job is running. You can see the status of each jobs, how it's running. For example, the dark green is complete, the right green is running and the red is error. The next one is the calendar view. This one is similar to GitHub, where you can see the job in the past that, okay, it's run smoothly. And the last one is a tree view, where you can see the detail in each subtask. And you can also view the log from here, view the render or XCOM, which is the template of Apache Airflow. And for the XCOM, it is used for internal communication. So, yeah. And this one, you can see more detail about the time that this is running in Apache Airflow. You can see from this diagram. And next thing is about the Apache Airflow basic components. For example, they provide the sensor. Sensor is used for wait for and specific event. For example, we will have the SFTP operator sensor, where it will waiting file for SFTP, or you can sensor in Google Cloud Storage as well. Yeah, in this term, it's called poking for a file. Next is operator. Operator is the component where it will run the action on you can put the code to run an actual action. And lastly is the hook. Hook is the interface to the external system or service. It is used behind the scene of both sensor and operator to customize sensor. Maybe we don't need to use hook directly, but we will. If we customize the sensor operator, it is useful to use the hook. Okay, let's see the demo code. I'm going to share the screen to the Google Cloud platform. Here is my demo project. As I mentioned before, for the Cloud Composer, we can create a cluster easily from this UI. And in this UI, maybe it takes time to create a cluster. For example, like it can take up to 30 minutes to get a cluster. But unfortunately, it doesn't have the region in Singapore. You may need to go to Tokyo to get the cluster. And you can see the Airflow UI from here. This one, it is managed by the Cloud IAP, where you will need to log in with the Google Cloud. Yeah, and the next one is the log. We can also see the log from the logging system. And in here, we can see the log explorer similar in the cloud logging. And the DAG folder in the Google Cloud platform, all the DAGs or the pipeline, it will keep in Google Cloud Storage, where you can find the bucket. Okay, let's get started. In this demo, let's start from the DAGs here. Normally, when we see the DAGs, the very first one is the Airflow monitoring. We can see the Airflow monitoring and see the graph view, and also the code and log. This one is very simple for the monitoring. For the part of for the Airflow DAGs, it will contain first we need to import the Airflow, and then we can define the arguments and create the DAGs with tasks. For if you're going to run bash, it's called bash operator. Yeah, the DAG stands for directed acyclic graph. You can name the DAG, and this one will create the very basic one task of echo command, echo test. Yeah, and when we need to develop a DAG, we will put into the bucket. For example, when we create the Google Cloud Composer, it will have the bucket here where you can put the DAG in here. Here is my sample DAGs. Let's see it using Cloud Shell. I developed my DAG with a Cloud editor here, where you can write the Python code from the web browser. Firstly, will initialize. In my pipeline, I will create using the Coinbase API, Coindesk. Sorry, for the Coindesk, this is the website to see the Bitcoin pricing. It is for the demo. Yeah, and the Coindesk will provide the Bitcoin price in API, as we can see from this API here. It's returned in JSON format, and we can just make the HTTP GET request to get that. Yeah, but for the red error from the Pylon here, you don't need to worry much about that because the Google Cloud Shell editor doesn't have the dependency of Airflow, so it may give an error. Yeah, and we can define the variable that we are using it here. Similarly to previous DAX, we're going to import the DAX first, and then we are going to make the request and save it as the CSV in the file name here. I indicate the file name as the call price of CSV. And in the DAX, it will start with the Python operator to get the DAX. And here with here we can create a Python code to make call to previous REST request that we wrote previously, and then it will save the file. And after we got the file, we will load it into the BigQuery in here. So, yeah, which one I will use the bash command line to use the BQ load and put it into the dataset. And because of the limited of time, let's see the DAX. Let's see how it's interpret the DAX. In the graph view, we are going to see that, okay, it will get the data first with the Python operator, and it will load to the BigQuery in the next slide. Yep. And we can see the code here because maybe this one I run it very frequently, so the DAX is get fail, but you can see the code later in my GitHub, and that, okay, the data it is saved, and we can see that we can get the value here in 3 columns, and then it will insert to the BigQuery. Yeah, so this one, the benefit, as I mentioned, to wrap up, the benefit of Apache Airflow is it will have everything in the one single platform where you can see the job execution run, you can see the all the DAX. For example, in my workplace, I develop the Google Apache Airflow with like 20 jobs running every day, and it is easier to manage. And then let's go back to our slide. Okay, so the key to take away is choosing the right solution for the data pipeline is depend on requirements and workload, whether your use case is in serverless. I would suggest for the Cloud Run and Cloud function previously because it is really cheaper and faster to build. But if your workload more into the ETL job that is require develop multiple jobs, or I would suggest the Cloud Composer for the easier to manage, where you can see the UI and see all the integration. And thank you. That is for me. Let's connect it to my LinkedIn and GitHub here. And I'm really pleased to join us. And also thank you, Yuan and Open Developer Academy for shaping up this presentation. Thank you.
Thanks a lot, Phone. Really love the slide where you summarized all the different tools. I feel like you summarized George and Stanley's whatever tools they used as well.
Yeah,
awesome.
It's a bit long.
Nice wrap up.
I think we have time to go through one question from the registration. Let me just show it up on screen. So yeah, how do you handle errors with automation logic, which may have accidentally altered data? And what would be the best way to avoid this?
Yeah, for this one, I would suggest we will have like the two environment to manage this, Yeah, because maybe on the first and for the first production, we would like nothing to fail in the production. And from my experience, I will create the staging environment, and I will try to ingest the data into another BigQuery data set. And also, if anything accidentally alter the data, in my case, I use the insert date as a timestamp. That I will also put the timestamp into every row that I insert. If some row is bad, I will remove and rerun the job, something like that. Yeah. So for prevent anything bad that happen to the data, I use the unique timestamp and query for the unique timestamp. Yeah.
Nice.
But
Thanks.
but the best way to avoid the error that can happen is maybe we can using the unit test to test your function on the processing function first. Then maybe doing the integration test to the other components, and then end-to-end test to test the whole pipeline. Yeah. Thank you.
Thanks a lot. We have a comment from Wei Yuan. Yay! Wei Yuan is one of our mentor for Google Women Developer Academy. And yeah, thanks for mentoring Phone as well, Wei Yuan. Yeah, we have a few other congratulatory messages on YouTube. But yeah, thanks a lot, Phone. We'll move you backstage because we are running a little tight on time. But feel free to connect with Phone through LinkedIn or on her GitHub. Thank you so much.
Thanks for joining us today.
Bye-bye.
Yep, and thanks a lot, George, Stanley, and Phone for such an insightful session today. If you would like to rewatch the session, if you joined us halfway, don't worry, this recording is up on our YouTube and Facebook page. And you can also stay connected with us by signing up to our mailing list that is available on our website. And also our event, Startup Coffee Chat, is happening next Thursday. We have the head of product from Xendit, which is the same company that Stanley is from. Do join us to learn from product leaders from Xendit and Wise on how they are building products in a regulated environment.
And last but not least, we also want to hear your feedback about this event. So if you provide your email address, you can stand a chance to win some gift. We'll be selecting 5 lucky winners who fill up the feedback form to get some special swags. So do remember to check your inbox later this week if you fill up our feedback form. Meanwhile, stay tuned for all our upcoming events on our website and social channels, and we look forward to have you join us again.
Thanks, everyone. Bye.
Bye, all.